Here's the question. What is the fastest model for object detection?
YOLO, man.
No one can deny that YOLO is one of the fastest models for object detection. Last time I made a simple AimBot with a TensorFlow hub, but the problem was it was too slow. So this time I'm going to introduce how to use YOLO with OpenCV and make AimBot faster. The required Python libraries are as follows. But if you want to use GPU for OpenCV, you have to build your own library. In the last part of this video, I will show you how to build OpenCV for GPU. Okay, let's get it started. First, we need to download the configuration file and weights from the YOLO website. I'm going to compare Tiny YOLO and YOLO 320. The Tiny is super fast, but the accuracy is super low, and 320 just has average accuracy and speed. First, load the YOLO network model from configure file and weight file. If you have built OpenCV GPU, you can enable CUDA with this code. But if you're not, you can just set this code and determine layers here and get a rectangle from a window of Counter-Strike. So while getting a frame of Counter-Strike, construct a blob from the frame and then perform a forward pass of the YOLO object detector. Here we can change blob size. It is usually 416, but we can try many different sizes according to models. Output has information about bounding boxes, class, and confidence. I set 0.7 as a threshold, and class ID 0 is for the human. Scale the bounding box back to the size of image. YOLO returns the center of detected, so I make it as a box. Here, NMS boxes does non-maximum suppression to converge duplicated boxes. Now calculate distance between boxes and crosshair and move the mouse and shoot. When we compare it with the TensorFlow hub, you can see YOLO is much faster. Tiny version shows almost like a real-time performance, but as you can see, it does not detect well. Now how to build an OpenCV GPU library. You can just follow this guideline I commented. So what we need for this, first Visual Studio and CMake and OpenCV sources and OpenCV extra modules and Python 3. First, you need to download OpenCV sources and extra modules. Since the extra module is for version 4.4.0, so please download OpenCV version 4.4.0. After downloading it, extract and make a build folder. Now you need to generate code with CMake. First, set the source code as OpenCV folder and set where to build to your build folder just you made. And hit the configure button and set your platform. After configuring is done, you need to check these three values and set an extra module pass. Hit the configure button again. After configuration is done, now check CUDA fast math and set your CUDA architecture. You can find your GPU architecture from Wikipedia. Then hit the configure button again. After configuration is done, hit generate. It will take some time and CMake is done. Go to your build folder and open OpenCV project. Go to CMake target and build the old build. It will take around 30 minutes. After finish building, build install. Then everything is done. But all your building process must be successful. So if you successfully built your OpenCV, you can check in Python. Again, you can just follow the guideline I commented. Thanks for watching. I hope you enjoyed this video.